this is the last part of the lecture, and it's really short. It's only 3 slides. So when I got done with the last one, I went, oh, well, I'm just going to put these together. I know you guys really want another assignment, but we'll pass on this one. So we're going to finish up chapter 13. And again, this part will be with part 3 because it's only 3 slides. So the last part of the notes talk about genetic variation, okay, due to the sexual life cycles. Okay, when you are talking about sexual reproduction, you're taking genetic information from 2 different individuals and combining them. So now you're going to have an organism that has different information than mom and pop. Okay. And that's how, when we talk about evolution, you'll see, what happened there was the ones that had the better genetics actually produced more offspring. So then they ended up changing something in their background, changing something about their characteristics, like giraffes having longer legs so they could eat better, reach higher in the trees and so on. So whenever you have genetic variation, there's going to be some, the individuals created are going to have different characteristics. And I don't mean like they're going to have 3 eyeballs and 6 ears or whatever, but their characteristics are going to be different than their parents. They're going to be similar, but they're not going to be the same. Now, things can happen. We can have what they call mutations. Okay, we can change that DNA, and we talked a little bit about that before, but DNA can be changed if you're exposed to certain things like carcinogens, things that cause cancer, X-rays, UV rays. One of the worst ones, you guys, is cigarette smoke. So if you smoke, stop it. Okay, all of those things can change in DNA, and if that characteristic is passed on, then now you have, instead of having the original source of genetics, you have a different one. You have something that's different, and it couldn't be good. It can be, mutations can be as simple as a birthmark, but they can be something that's, causes the organism actually to pass away. So, it depends on what's being changed, but you can have deadly mutations and you can have ones that, aren't really a big deal. Okay. So mutations create different versions of the genes called alleles. Okay, and we'll talk more about that again when we talk about genetics. But you can change a little bit of that DNA and you can end up with a different gene. So when you reshuffle the alleles, when you reshuffle that DNA during sexual reproduction, now you're going to get a variation. Okay, something that neither mom or dad has, but because it was mutated. Okay, and that's important in evolution. Okay, natural selection means the ones that survive better in an environment are going to produce more offspring. That's kind of what they call natural selection. Okay, the ones that are better suited for an environment are the ones that are going to survive. Well, okay, their genetics are going to be passed on, whereas the ones that didn't have favorable ones, like giraffes with really short legs, they're going to die out because they can't eat. So you have this natural selection, and a lot of that started from genetic variation. Okay, and sexual reproduction allows for that. Okay, if you have non-sexual, like, bacteria split in 2, the bacteria are the same, and so you don't get any variation there. Okay, but the sexual reproduction, then, if it's a genetic variation that's actually helpful, then it's going to be passed on, because once the mutation occurs, then it's going to, like all other characteristics, going to be passed on. Okay, animals always reproduce. Animals always reproduce sexually. There's very few that produce. And when we're talking animals, we're talking like very small ones, like sponges. And I know most people don't think of sponges as animals, but they are. So when we're talking about them, we're talking about, really low. We're not talking about mammals. We're not talking about even like fish or whatever. When the animals that reproduce asexually is really, really, really rare. And like I said, it's the really lower forms. Okay. Here they have a rotifer. A rotifer is little, you have to use a microscope to see them. And again, they increase their genetic diversity through changing their genes. Okay, but again, that's a one-cell organism. Okay, so, and again, this was just going through what happens with them. But again, remember, see, this is the crossing over right here. They're connected, and then what happens is a small part of one of them, one of these, instead of being like it was before, all red, these 2 cross their little piece there. And so that's what they mean by crossing over. And now you're going to have a new gene, a new chromosome that is different than, most of your chromosomes are supposed to be either from mom or dad. In this case, it was a piece of mom and dad. And that happens in metaphase, in meiosis 1, geez. And meiosis when that can happen. And again, it's because you got all 4 of them all scrunched together, and then you're going to get crossing over. So you're going to end up with new genes. And this happens with us. It happens with humans. It happens with a lot of the upper level, if you want to call them that, organisms. They'll get this crossing over, and that happens in there. And again, we'll talk more about that when we talk about genetics. So now we're done with chapter 13.